Hello, in this lecture we'll answer on two questions. In the first question we'll find out the area of this square ABCD. In the second question we'll find out the size of this angle theta in triangle TOE. So we'll start with the first question. In the drawing we have square ABCD. Note that line segment AP equals to 5 units, line segment BP equals to 3 units, line segment CP equals to 6 units, and our mission is to find out the area of this square ABCD. Okay, so first of all we'll do a construction. We'll extend side DC of the square by a straight line. And then from point P we'll go perpendicular on the extended DC. So here, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point P and the extended DC as N. In the next step, we'll do another construction from point B. We'll draw perpendicular on PN. Again, from point B, this point, we'll draw perpendicular on PN. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. We'll define side BM, this side as A, that is to say BM equals to A unit in its length, and we define the length of side PM as B. In the next step, we'll implement the Pythagoras theorem on the right triangle PBM. This right triangle PBM. So according to the Pythagoras theorem, in the right triangle PBM, here by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse PB is equal to 3 units according to what is given as the question. So, here, so right down there, the hypotenuse is PB, therefore the square of the hypotenuse is PB squared. and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to PM square plus BM square. Repeat again. The right triangle PBM, according to the Pythagoras theorem, PB square equals to PM square plus BM square. Okay. So here PB equals to 3 units according to what is given as the question. Therefore PB square is 3 squared, that is 9, and it is equal to PM square. PM equals to B, therefore PM square is B square plus BM square. BM equals to A according to our definition, therefore BM square will be equal to A square. So here, conclusion, we found out that according to equation number 1, A square plus B square equals to 9. Here, according to equation number 1, here, A square plus B square equals to 9. We know that all the angles inside the square are right angles. So here, this angle equals to square ABCD, this angle equals to 90 degrees. This angle will be also equal to 90 degrees. This angle equals to 90 degrees. And finally, this angle will be also equal to 90 degrees. Here, if we focus here, DC is one side of square ABCD, therefore it is absolutely a straight line. Then we extended the straight line DC by a straight line. And we got line segment DN. When you extend a straight line by a straight line, the result must be a straight line. So the result of extending the straight line DC by a straight line is CN. Therefore CN is a straight line. I write it down. CN is a straight line. Because when you extend a straight line by a straight line, the result must be a straight line. So CN is a straight line. So if we focus on the upper side, actually DN is a straight line. Okay, here DN is a straight line. When we extended the straight line DC by a straight line, the result is DN, and therefore DN is a straight line. Okay, here DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So each angles we have at the upper side of DN at point C, we have this angle that is equal to 90 degrees plus this angle that is the missing angle. So therefore this missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of DN at point C to 180 degrees, this angle must be equal to 90 degrees. according to rule number 3. Okay, so actually we found out that in quadrangle BMCN, again in this quadrangle BMCN, we have 1, 2 right angles. The sum of right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees. In order to complete the sum of the angles in this quadrangle BMCN to 360 degrees, this angle must be equal to 90 degrees. According to the rule that the sum of the angles in any quadrangle is equal to 360 degrees, this angle must be equal to 90 degrees. Okay? So, here we will focus on the lower side of segment line AM. In the lower side at point B, we have this angle that is equal to 90 degrees plus this angle that is also equal to 90 degrees. So, therefore, the sum of those two angles is 90 degrees plus 90 degrees. It is equal to 180 degrees. Therefore, we can say that angle ABM is equal to 180 degrees. I write it down. Angle ABM is equal to 180 degrees. Okay, here angle ABM equals to 180 degrees. And therefore, angle ABM is a straight line. Okay, angle ABM is a straight line because any angle that is equal to 90 degrees, 280 degrees, it is a straight line. So if angle ABM is a straight line, then line segment ABM is a straight line. Line segment ABM is also a straight line. And therefore AM is also a straight line. AM is a straight line. Write it down. AM is a straight line. AM is a straight line. So we know that AM is a straight line. AP, it is given as the equation that is a straight line, it is equal to 5 units. And there, PM is part of a perpendicular PN, therefore it is absolutely a straight line. Therefore, shape APM, this shape APM, shape APM is a right triangle because this angle equals to 90 degrees. Shape APM is a right triangle. Okay, so we'll focus on the right triangle, triangle APM. And we will implement the Pythagoras theorem on the right triangle, triangle APM. By PT is a relation for Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is AP, therefore the square of the hypotenuse is AP squared. And it must be equal to the sum of the squares of the perpendiculars, that is to say must be equal to PM square plus AM square. Repeat again. In the right triangle, triangle APM, according to the Pythagoras theorem, AP square equals to PM square plus AM square. Okay? AP equals to 5 units according to what is given as the question, therefore AP square is 5 squared, that is 25. And it is equal to PM square. PM is B, therefore PM square is B square plus AM square. What is the length of AM? We define the side length of square ABCD as X. Therefore, all of its sides will be equal to X units in their lengths. So, what is the length of line segment AM? The length of side AM equals to X plus A. Again, the length of AM is equal to X plus A. So here AM equals to X plus A, therefore AM square will be equal to X plus A square. So here, according to equation number 2, we found out that 25 equals to B square plus X plus A square. Here we'll open the brackets on this side of equation number 2, and we get that according to equation number 2, $25 equals to B square plus X plus A square. X plus A square equals to X square plus A square plus 2 times X times A. So in this equation, equation number 2, we have A square plus B square. And we have already found out that here, actually we have here, according to this equation, equation number 2, we found out that 25 equals to A square plus X square plus B square plus 2 times AX. So in this equation, equation number 2, we have A square plus B square. But according to equation number 1, A square plus B square equals to 9. Therefore, we can substitute A square plus B square in equation number 2 by 9. We'll do it now, and we'll get that according to equation number 2. $25 equals to A square plus B square is 9 according to equation number 1 plus X square plus 2AX. So here we subtract 9 from this equation, equation number 2, and we will get that according to equation number 2, 25 minus 9 is 16, and it is equal to X squared plus 2AX. So here we subtract X squared from this equation, equation number 2, and we get that according to equation number 2, minus x squared equals to 2ax. So here we divide this equation number 2 by 2x, and we get that according to equation number 2, a equals to 16 minus x squared over 2x. So we found out the value a in terms of x. Okay. Here we've already found out that quadrilateral BMCN, this quadrilateral has 4 right angles. Therefore, we will relate to quadrilateral BMCN as a rectangle. I write it down. Quadrilateral BMCN is a rectangle. Why? Because it has 4 right angles. Okay. Quadrilateral BMCN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN, but we know that BM equals to A according to our definition. So we can write here BM equals to A. And from this expression, A equals to BM equals to CN, we will derive that CN is also equals to A. So we can write here that Cn equals to A. Likewise, according to the third rule, that the opposite sides of a rectangle are equal to each other, we'll get that BC equals to MN. BC equals to MN. But according to our definition, BC equals to X. Here BC equals to X. And from this equation, X equals to BC equals to MN, we will derive that MN is also equals to X. MN is equal to X. In the next step, we'll implement the Pythagoras theorem in the right big triangle, triangle PCN. So, according to the Pythagoras theorem, in the right big triangle, triangle PCN, by PT, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Only to the Pythagoras theorem. The hypotenuse of the right triangle, triangle PCN is PC. Therefore, the square of the hypotenuse is PC squared, and it must be equal to the sum of the squares of the perpendiculars. That is to say, it must be equal to Pn squared plus Cn squared. I repeat again, in the right triangle, triangle PCN, according to the Pythagoras theorem, PC squared equals to Pn squared plus Cn squared. it is given us in the question that PC equals to 6 units. Therefore PC squared is 6 squared, it is 36, and it is equal to Pn squared. What is the length of Pn? Pn equals to B plus X. Pn equals to B plus actually Pn equals to B small b, not capital B. So here Pn equals to small b, Pm equals to small b, therefore Pn equals to B plus X. Therefore Pn squared will be equal to B plus X squared plus Cn squared. Cn equals to A, therefore Cn squared equals to A squared. So in conclusion, I found out that according to equation number 3, 36 equals to B plus X squared plus A squared. Here we'll open the brackets on this side of equation number 3, and we get that according to equation number 3, equals to B plus X squared equals to B squared plus X squared plus 2 times Bx plus A squared. So in this equation number 3, we have B squared plus A squared, or A squared plus B squared, and we have already found out that according to equation number 1, A squared plus B squared equals to 9, therefore we can substitute A squared plus B squared in equation number 3 by 9 from equation number 1. So we'll do it and we'll get that according to equation number 3, 36 equals to 9 plus X squared plus 2bx. So here we subtract 9 from this equation number 3, and we get that according to equation number 3, 36 minus 9 is 27. It is equal to X squared plus 2bx. So here we subtract X squared from this equation number 3, and we get that according to equation number 3, 27 minus X squared equals to 2bx. So here we divide this equation number 3 by 2x, and we get that according to equation number 3, V equals to 27 minus X squared over 2x. Okay, so actually we have the values of A and B in terms of X. You know that according to equation number 1, A squared plus B squared equals to 9. So in the next step, we substitute A and B in this equation, equation number 1, by the values that we found for A and B. So here we already found out that A equals to 16 minus x squared over 2x. Therefore, if we square A, we get A squared. So we square this expression in order to get A squared plus B squared. Just like the formula that B equals to 27 minus x squared over 2x. Now we'll square this expression in order to get the value of B squared. And according to equation number 1, A squared plus B squared equals to 9. So this expression in total equals to 9. Okay, now we'll open the brackets of those two expressions, and we get that 16 minus x squared equals to 16 squared, that is 256, plus x squared squared is x to the power of 4 minus 2 times 16 times x squared over 2x squared is 4x squared and here we'll open the brackets of this expression. In the denominator we will have also 4x squared, so we have the same, those two expressions have the same denominator, therefore we can add the denominator of this expression to the denominator of this expression. Why? Because they have the same. We can add the numerator of this expression to the numerator of this expression. Why? Because they have the same denominator, that is 4x squared. So we do it now, we get that 27 squared equals to 729 plus x squared is x to the power of 4 minus 2 times 27 is minus 54 x squared. Okay, and it is actually, we know that it is equal to 9. Here it is equal to 9. So we actually found out that according to equation number 1, 256 plus 729 is 985. X to the power of 4 plus x to the power of 4 is 2 times x to the power of 4 minus 2 times 16 is minus 32, so this expression equals to in total to minus 32x squared minus 54x squared divided by 4x squared, it is equal to 9. So we got this expression. Here we multiply this expression by 4x squared, and we get that according to equation number 1, two times x to the power of 4 minus 32x squared minus 54x squared is minus 86x squared plus 985 equals to 9 times 4x squared is 36x squared. So here we subtract 36x squared from this equation, equation number 1, and we get that according to equation number 1, 2 times x to the power of 4, we have minus 86x squared minus 36x squared is minus 122x squared plus 985 is equal to 0. So here we define x squared as z in order to get a quadratic equation. So x squared equals to z. If x squared equals to z, it means that x to the power of 4 will be equal to z squared. Therefore, this expression two x squared, 2x to the power of 4 will be equal to 2z squared minus 122, and x squared equals to z. Therefore, we substitute x squared by z. So it will be minus 122z plus 985 is equal to 0. So here we have a quadratic equation, and you know that the general formula for a quadratic equation the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. Okay, in our specific quadratic equation, the coefficient a equals to 2, the coefficient b equals to minus 122, and finally the coefficient c equals to 985. And the variable that we are looking for is z. So we put the data inside the formula for x, and we find out the value of z because x equals to z. And we get that z equals to minus b. b is minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. So b is minus 122, therefore b squared is 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, and minus, so it is minus 4 times a, c. So minus 8 times c, that is 985, so minus 8 times 985 is 7,880. all divided by 2a. A is 2, so 2a is 2 times 2, that is 4. So in conclusion, we found out that z equals to 122 plus minus 14,884 minus 7,880 is 7,004 over 4. So here we have z equals to 122 plus minus the square root of 7,004 is 83.6899. So here we will have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. So here z equals to 122 plus 83.6899 is 205.6899 over 4. So z equals to 205.6899 over 4 is equal to 51.4224. According to our definition, z equals to x squared. That is to say, so z equals to x squared, that is equal to 51.4224. So we take a root out of 51.4224 and we get the value of x. The square root of 51.4224 will give us the value of x, so we got that the value of x is equal to 7.17 units. Actually, it is impossible that x equals to 7.17 units. Here we have mb is equal to, here we have square a b c d, ab equals to x. Okay, so if we focus on the right triangle, triangle APM, in the right triangle, triangle APM, the hypotenuse AP equals to 5 units. And the hypotenuse in any right triangle is the biggest side. That is to say, AP must be greater than AM. The hypotenuse AP must be greater than AM. If the hypotenuse AP must be greater than AM, let alone that it must be equal to, it must be greater than part of AM. That is AB. AB is part of AM. Therefore, the hypotenuse AP must be also greater than AM. Okay, I found out that the hypotenuse AP the hypotenuse AP that is equal to 5 units must be greater than AM, that is equal to X. So from this equation, 5 equals to AM is greater than AM equals to X. We will derive that X must be less than 5 units. But we just right now found out that X equals to 7.17 units, that is greater than 5 units. So we have a contradiction, because X must be less than 5 units, but we found out that X is greater than 5 units. That is to say, this solution is not correct. We'll cancel this solution, and we left only the second solution, that Z equals to Z equals to 122 minus 83.6899 over 4. Okay, so we get here that Z equals to 122 minus 83.6899 is 38.3101, and if we divide it by 4, we get that Z equals to 9.5775 square units. So the area of square ABCD, you can see the area of this square ABCD, it is equal to X squared. What we just right now found out that X squared, that is equal to Z, it is equal to 9.5775 square units. Repeat again, I found out that the area of this square ABCD equals to X squared, of course, and we just now found out that X squared, that is equal to Z according to our definition, it is equal to 9.5775 square units. And what is the value of X itself? We should remember that X must be less than the hypotenuse, that is equal to the hypotenuse AP, that is equal to 5 units. So X must be less than 5 units, and indeed, if we take the root of X squared, we get that X equals to 3.09 units, that is of course less than 5 units. Therefore, indeed, the answer to the question is that the area of square ABCD equals to 9.5775 square units. So we finished with the first question. In the next step, I will present to you the second question. So in the drawing we have a right triangle ABC. This angle ABC equals to 90 degrees. Inside the right triangle ABC, we have a circle, and inside the circle we have triangle DOE. This triangle DOE. And our mission is to find out of this angle that we can call it also angle ODE. So our mission is to find out the size of this angle theta, that we also can call it angle ODE. Okay? And we actually know that line segment AD equals to line segment EC, and we also know that DE is twice as long as CE, and also DE is twice as long as AD. Okay, so first of all, we will define DE as 2A. Okay, here DE equals to 2A according to our definition, and we use this equation that is given to us. So here we'll get that AD equals to EC equals to DE over 2, and according to our definition, DE equals to 2A, so substitute DE by 2A. So it is 2A over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. So it is equal to A. So in conclusion, we found out that AD equals to EC, and it is equal to A. So we found out that AD equals to A units, and EC is also equals to A units. Okay. In the next step, I will present to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. The center of the circle is at point O. You draw perpendicular on chord CD, and according to this rule number 4, the perpendicular OM bisects chord CD. That is to say, CM equals to MD. And we also say that the first half of CM of CD, that is CM, it is equal to CD over 2, and the second half of CD, that is MD, it is also equals to CD over 2. So we actually can implement this rule number 4 in our drawing. Why? Because in our drawing we have the center of this circle that is at point O. From the center of this circle that is point O, we'll draw perpendicular on chord DE. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We'll define the touching point of the perpendicular from point O and chord DE as T. According to rule number 4, the perpendicular OT bisects chord DE. That is to say, according to rule number 4, DT is equal to TE. And because of the fact that the perpendicular OT bisect chord DE, it means that it divides it into two halves. The first half is dt, that's to say dt equals to dE over 2, and the second half is TE, that is to say TE is also equals to dE over 2. So in conclusion, we found out that dE equals to TE equals to dE over 2. But according to our definition, dE equals to 2a, therefore we can substitute dE by 2a, and we have here 2a over 2. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled, and we left with a. So in conclusion, we found out that dt equals to TE, that is equal to a. We found out that dt equals to a, and we found out also that TE is also equals to a. Okay? So, in the next step, we will define the point of tendency of tangent AB with this circle as point M, and we will define the point of tendency of tangent BC with this circle as point N. We will join points M and O together by a straight line. Point O is the center of the circle. Point M is the point of the circle itself. Therefore, OM is the radius of the circle. We define the radius of the circle as R. Therefore, OM equals to R. And we have M is the point of tendency. Therefore, we have the radius OM that is drawn to the point of tendency. Therefore, according to rule number 1, that a tangent to a circle is perpendicular to the radius drawn to its point of tendency, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. Likewise, we join points O and N together by a straight line. Repeat again, point O is the center of the circle, point N is the point of the circle itself. This is exactly the definition of a radius. Therefore, ON is the radius of this circle that is equal to R according to our definition. N is the point of tendency, and we have the radius ON that is drawn to the point of tendency. Therefore, according to rule number 1, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we actually found out that inside quadrangle OMBN, we have 1, 2, 3 right angles. Again, inside quadrangle OMBN, we have 3 right angles. The sum of 3 right angles is 270 degrees. Therefore, the fourth angle must be equal to 90 degrees. In order to complete the sum of the angles in this quadrangle to 360 degrees, this angle must be equal to 90 degrees. Okay, so inside quadrangle MOBN, we have 4 right angles. Therefore, we can relate to quadrangle MOBN as a rectangle. I will write it down. Quadrangle MOBN is a rectangle. Why? Because it has 4 right angles. Okay, quadrangle MOBN is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. MO equals to BN. But MO equals to R. Okay, MO equals to R. And from this equation, R equals to MO equals to BN, we will derive that BN is also equals to R. BN is also equals to R. So we can write down that BN equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we will get that ON equals to MB. ON equals to MB, but we have already found out that ON equals to R, so we can write here ON equals to R. And from this equation, R equals to ON equals to MB, we will derive that MB is also equals to R. MB is also equals to R. And right here that MB is also equals to R. We actually found out that quadrilateral MOBN is not a rectangle but a square. Write it down. Quadrilateral MOBN is a square because all of its sides are equal to R. Okay. In the next step, I will present to you a new rule that is actually rule number 10. According to rule number 10, if you have this circle and we have the external point P here, and from point P we have tangent PA that is tangent to this circle at point A, and we have also from point P a straight line that intersects with the circle at 2 points, point B and point C. Again, we have tangent PA and a straight line that intersects with the circle at point B and point C. So if this is the data that has been given to us, then the following equation will be true. Here PA squared will be equal to PB times PC. Again, PA squared will be equal to PB times PC. AP squared equals to PB times PC. We can implement rule number 10 in our drawing. Why? Because in our drawing, if we focus on the external point C, from the external point C, we have tangent CN, and we have the straight line that intersects with this circle at point E and then point D. Therefore, we can implement here rule number 10. According to rule number 10, we get that Cn squared equals to Ce times Cd. Again, Cn squared equals to Ce times Cd. So write it down. Cn squared equals to Ce times Cd. So according to rule number 10, if we focus on the external point C, we can implement rule number 10, and according to rule number 10, we get that Cn squared equals to Ce times Cd. So Cn squared equals to Ce. Ce is 8, therefore EC is 8, therefore we can substitute EC by 8. EC or Ce it is 8. So we substitute EC by 8. What is the value of CD? The value of CD is A plus A plus A, that is 3A. So in conclusion, we found out that according to rule number 10, Cn squared equals to A times 3A. So Cn squared equals to a times 3a is 3a squared. So here we take a root out of this equation and we get that Cn equals to the square root of 3a squared is square root of 3 times a. So we actually found out that Cn equals to the square root of 3 times a. So I can write down here that Cn equals to the square root of 3 times a. Likewise, we focus on the external point, point A. According to rule number 10, so first of all, you can say that from the external point, point A, we have tangent AM, and we have a straight line from point A that intersects with this circle at point D and at point E. Therefore, we can implement here rule number 10. According to rule number 10, we will get that AM squared is equal to AD times AE. AD times AE. Because again, on the external point, point A, we implemented rule number 10, and we got that according to rule number 10, AM squared equals to AD times AE. So here, AM squared equals to AD. AD equals to A, so substitute AD by A times AE. What is the value of AE? It's very easy to see from the drawing that AE equals to A plus A plus A, that is 3A. So substitute AE by 3A. So in conclusion, we found out that according to rule number 10, AM squared equals to A times 3A. So AM squared equals to A times 3A is 3A squared. So we found out that AM squared equals to 3A squared. Here we take a root for this equation and we get that AM equals to the square root of 3A squared. The square root of 3A squared is square root of 3 times A. So we found out that AM equals to square root of 3 times A. So I will write it down. AM equals to the square root of 3 times A. In the next step, I will copy the right triangle, triangle ABC in a new page, and we will analyze triangle ABC. Okay. It is very easy to see from the drawing that side AB equals to square root of 3 times A plus R. Again, side AB equals to square root of 3 times A plus R. And side BC is also equals to square root of 3 times A plus R. So this is the right triangle, triangle ABC that I copied from the original drawing. It's already mentioned here. Those two sides, they are equal to each other because of the fact that they are both equal to square root of 3 times a plus r. And we have the rule that in front of equal sides in the triangle, there are equal angles. So those two angles are located in front of equal sides, therefore they are equal to each other. So if this angle equals to theta, then this angle must be also equal to theta because of the fact that those two angles are equal to each other. So this is a right triangle. This angle equals to 90 degrees, therefore the other two angles must be also equal to 90 degrees in order to complete the sum of the angles in this triangle to 180 degrees. The other two angles must be also equal to 90 degrees. Okay? That is to say, theta plus theta must be equal to 90 degrees. I write it down. Theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta, and 2 theta equals to 90 degrees. We divide this equation by 2 and we get that theta equals to 90 degrees over 2 is 45 degrees. So we found out that each angle equals to 45 degrees. So actually we found out that triangle ABC is not only a right triangle, but it is also an isosceles triangle. So in triangle ABC, it is very easy to see that cosine 45 degrees, if we relate to this angle, cosine 45 degrees is equal to BC over AC. Repeat again. Cosine 45 degrees in the right triangle, triangle ABC equals to BC over AC. Before I continue, what is the length of the hypotenuse AC? Here it is very easy to see from the drawing that AC equals to A plus A plus A plus A, that is 4A. So you can write down that AC equals to 4A. So cosine 45 degrees equals to BC over AC. We have already found out that BC equals to square root of 3 times A plus R. So we substitute BC by square root of 3 times A plus R over AC. AC equals to 4A, therefore we substitute AC by 4A. So in conclusion, we found out that cosine 45 degrees equals to square root of 3 times A plus R over 4A. Cosine 45 degrees equals to 1 over square root of 2, so we substitute cosine 45 degrees by 1 over square root of 2, and it is equal to square root of 3 times A plus R over 4A. Here we multiply this equation by 4A, and we will get that 4A over square root of 2 equals to square root of 3 times A plus R. So here we substitute 4 by 2 times 2, and we get that 2 times 2 times A over square root of 2 equals to square root of 3 times a plus r. Here we substitute 1, 2 by square root of 2 times square root of 2, so we get the 2 times 2, and as I already mentioned, we substitute 2 by square root of 2 times square root of 2 times a over square root of 2 equals to square root of 3 times a plus r. So here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. What is left from this equation after cancel square root of 2? In this side of the equation we left only with 2 times square root of 2 times a, that is equal to square root of 3 times a plus r. Here we subtract square root of 3 times a from this equation, and we get that 2 times square root of 2 times a minus square root of 3 times a equals to r. So here we will take a as a common factor out of those two expressions. What is left from 2 times square root of 2 times a after we took from it a as a common factor? What is left is actually 2 times square root of 2. What is left from minus square root of 3 times a after we took from it a as a common factor? What is left is actually minus square root of 3, that is equal to r. Okay, so we actually found out that the radius of the circle r is equal to a times 2 times square root of 2 minus square root of 3. I repeat again. We actually found out that the radius of this circle r equals to a times 2 times square root of 2 minus square root of 3. Okay. In the next step, I will copy the green right triangle DTO, and we will analyze triangle DTO. So we have triangle DTO, it is the right triangle. What is the value of OD? O is the center of the circle, D is the point of the circle itself, therefore OD is the radius of the circle, that is equal to R. So DO equals to R, DT equals to A, and this is the angle that we are looking for, angle theta. So this is the right triangle DTO that are coming from the when you are going. In this right triangle DTO, it is very easy to see that cosine theta equals to dt over do. Again, cosine theta equals to dt over do. So I write it down. In the right triangle DTO, cosine theta is equal to dt over do. So cosine theta equals to dt equals to a, therefore we substitute dt by a over do. We just right now found out that do equals to r, so we substitute do by r. So cosine theta equals to a over r, but we have only found out that r here equals to a times 2 times square root of 2 minus square root of 3. So we have a in the numerator and a in the denominator, so a will get cancelled. So in conclusion, we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. So I write it down here. We found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. Okay? And we are looking for theta itself. In order to get theta itself, we will operate the opposite function of cosine, that is cosine minus 1, on the result. In this way, we get the value of theta itself. So we operate the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3. In this way, we get the value of theta itself. Okay? Again, we operated the opposite function on the result. That is 1 over 2 times square root of 2 minus square root of 3. And this way, you get the value of theta itself. So, and the opposite function of cosine theta, that is cosine minus 1, if you operated it on the result 1 over 2 times square root of 2 minus square root of 3, we get that the value of this expression is equal to theta, that is to say theta equals to 24.203 degrees. So we found out that the size of angle theta equals to 24.203 degrees. Here the side of this angle theta is equal to 24.203 degrees. Okay, that is the answer to the second question. In the next step, I will summarize the lecture. We start with the first question, of course. So in the drawing we have square ABCD, line segment AP equals to 5 units, line segment BP equals to 3 units, and line segment CP equals to 6 units, and our mission is to find out the area of this square ABCD. Okay, so first of all we did the construction. We extended side DC of the square by straight line, and then from point P we draw perpendicular on the extended DC. Again, from point P we draw perpendicular on the extended side DC. We define the touching point of the perpendicular from point P and the extended DC is M. So this again equals to 90 degrees, and this again also equals to 90 degrees according to our construction. Then we did a second construction. From point B we draw perpendicular on PN. Again, from point B we draw perpendicular on point. From point B we draw perpendicular on PN. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point B and PN as M. Okay. Then we define side PM as B and side BM as A. And then we implemented the Pythagoras theorem on the right triangle, triangle PBM. On this right triangle, triangle PBM. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, PB square equals to PM square plus MB square. Okay, here, the right triangle, triangle PBM. PB square equals to PM square plus BM square. AP equals to 3 units according to what is given as the question. Therefore, AP square is 3 squared, that is 9. PM equals to B according to our definition, therefore PM square will be equal to B square. And BM equals to A according to our definition, therefore BM square will be equal to A square. So in conclusion, we found out that according to equation number 1, A square plus B square equals to 9. Okay. We know that all the angles inside the square are right angles, so all those 4 angles are right angles in square ABCD. So DC is one side of the square, therefore it is absolutely a straight line. When we extended the straight line DC by a straight line, the result must be a straight line. Therefore DN must be a straight line. When you extend a straight line by straight line, the result, that is DN, must be also a straight line. So you can write down that DN is a straight line. So if we focus on the upper side of the straight line DN at point C, here the sum of the angles must be equal to 180 degrees according to rule number 3, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have on the upper side of DN at point C? We have this angle that is 90 degrees plus the missing angle. The missing angle must be also equal to 90 degrees. In order to complete the sum of the angles on the upper side of the end at point C to 180 degrees, this angle must be also equal to 90 degrees. Okay? So, actually, inside quadrilateral PMCN, we have 1 two three right angles. The sum of three right angles is 270 degrees. Therefore, the fourth angle must be also equal to 90 degrees in order to complete the sum of the angles in this quadrilateral to 360 degrees. This angle must be equal to 90 degrees. Therefore, if you focus on the lower side of segment line AM at point B, we have this angle that is equal to 90 degrees. This angle it is also equal to 90 degrees. So the sum of those two angles is 90 degrees plus 90 degrees, that is 180 degrees. So angle ABM equals to 180 degrees. Okay, here we found out that angle ABM equals to 180 degrees. If angle ABM equals to 90 degrees, it means that angle ABM is a straight line. Angle ABM is a straight line, so if angle ABM is a straight line, it means that line segment ABM is a straight line, and if line segment ABM is a straight line, it means that line segment AM is also a straight line. Line segment AM is a straight line. Okay? And we know that AP is also a straight line according to what is given as the question, and PM is a part of a perpendicular, therefore it is absolutely a straight line. So therefore we can conclude from it that shape APM, this shape APM is a right triangle. Okay, so if we focus on the right triangle, triangle APM, and we'll implement the Pythagoras theorem on the right triangle, this right triangle, triangle APM. According to the Pythagoras theorem, AP squared equals to PM squared plus AM squared. Again, in the right triangle APM, AP squared equals to PM squared plus AM squared. According to what is given as the equation, AP equals to 5. Therefore, AP squared is 5 squared, that is 25. And it is equal to PM squared. PM equals to B according to our definition, therefore PM squared is B squared plus AM squared. What is the value of AM? It's very easy to see from the drawing that AM equals to X plus A, therefore AM squared is X plus A squared. So in conclusion, we found out that according to equation number 2, AP squared equals 25 equals to B squared plus X plus A squared. Here we open the brackets on this side of equation number 2 and found out that 25 equals to B squared X plus A squared equals to X squared plus A squared plus 2 times Bx. So here we have B squared plus A squared in equation number 2. Again, we have B squared plus A squared in equation number 2. Therefore, we can substitute B squared plus A squared by 9 according to equation number 1, because A squared plus B squared equals to 9. So we substitute A squared plus B squared in this equation, equation number 2, by 9. And we got that 25 here. We actually found out that according to equation number 2, (25) equals to 9 plus x squared plus 2ax. So we subtracted 9 from this equation and found out that 25 minus 9 is 16, so 16 equals to x squared plus 2ax. We subtracted x squared from this equation and found out that 16 minus x squared equals to 2ax. Here we divided this equation by 2x, and finally we found out that a equals to 16 minus x squared over 2x. So we found out the value of a in terms of x. Okay. We have already found out that quadrilateral BMCN has 4 right angles, therefore quadrilateral BMCN a rectangle because it has 4 right angles, and we know that the opposite sides of a rectangle are equal to each other. That is to say, BM equals to CN. BM equals to CN, but according to our definition, BM equals to A. BM equals to A, and from this equation, A equals to BM equals to CN, we derive that CN is also equals to A. Here CN is also equals to A. Likewise, according to the sum that the opposite sides of a rectangle are equal to each other, we get that MN equals to BC. MN equals to BC, but according to our definition, BC equals to X. So for this equation, X equals to BC equals to MN, we derive that MN is also equals to X. Okay? And then we implemented the Pythagoras theorem on the right big triangle, triangle PCN. In the right big triangle, triangle PCN, PC square equals to PN square plus CN square. Repeat again, PC square equals to PN square plus CN square. PC equals to 6, therefore PC square is 6 squared, that is 36. And it is equal to Pn square. Pn equals to b plus x, therefore Pn square is b plus x squared, plus Cn square. Cn equals to a, therefore Cn square is a square. So in conclusion, we found out that according to equation number 3, 36 equals to b plus x squared plus a squared. Here we open the brackets on this side of equation number 3 and found out that 36 equals to b plus x squared is b squared plus x squared plus 2bx plus a square. So here we have a square plus b square in equation number 3. So we substitute a square plus b square by 9, because a square plus b square equals to 9 according to equation number 1. So here we did it when we got that 36 equals to 9 plus x squared plus 2bx. Here we subtracted 9 from this equation, equation number 3, and found out that 36 minus 9 is 27. That is equal to x squared plus 2bx. Here we subtracted x squared from this equation, equation number 3, and found out that 27 minus x squared equals to 2bx. Here we divided this equation, equation number 3, by 2x, and found out that b equals to 27x squared over 2x. So we have the values of a and b in terms of x. And according to equation number 1, a squared plus b squared equals to 9. Therefore, we can substitute a by the value that count for a. And we substitute b, we can substitute b by this value. And then we square it, and we get a squared plus b squared in terms of x. We did it, we substitute a by this expression and we square it. We substitute b by this expression and we square it. So a squared plus b squared equals to 9. We open the brackets on this side of equation number 1 and found out that 16 minus x squared equals to 16 squared, that is 256, plus x squared squared is x to the power of 4 minus 2 times 16 times x squared, plus 27 squared is 27 minus x squared equals to 27 squared, that is 729, plus x squared squared is x to the power of 4 minus 2 times 27 is minus 54, times x squared is minus 54 x squared, all divided by 4x squared. It is equal to 9. Then we multiply this equation by 4x squared. 2 times 16 is 32, so in total this equation, this expression will be equal to minus 32x squared. Okay. And 256 plus 729 is 985. So in total we found out that 985, we have x to the power of 4 plus x to the power of 4 is 2 times x to the power of 4, and we have minus 32, 16 times 2 is minus 32, so we got the expression that minus 32x squared minus 54x squared over 4x squared equals to 9. We multiply this equation by 4x squared and we found out that 4x squared times 9 is 36x squared, and here we have 2 times x to the power of 4, and minus 32x squared minus 54x squared is minus 86x squared plus 985 equals to 36x squared. Then we subtracted 36x squared from this equation, equation number 1, and found out that 2 times x to the power of 4 and minus 86x squared minus 36x squared is minus 122x squared plus 985 equals to 0. In order to get the quadratic equation, we defined x squared as z. So if x squared equals to z, it means that x to the power of 4 will be equal to z squared. Therefore, this equation in total will be equal to 2z squared. So it is 2z squared minus 122, and substitute x squared by z because x squared equals to z according to the definition, plus 985 equals to 0. So we have here a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. And here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the coefficient a equals to 2. The coefficient b equals to minus 122, and the coefficient c equals to 985. And the variable that we are looking for is z, so we put the data inside the equation here and found out that z equals to minus b. b equals to minus 122, therefore minus b is minus 122, that is plus 122, plus minus square root of b squared. b is minus 122, therefore b squared is minus 122 squared, that is 14,884, minus 4 times a is 2, so minus 4 times 2 is minus 8, and minus 8 times c, that is 985, is 7,880 over 4. Here, 14,884 minus 7,880 is equal to 7,004. So, in conclusion, I found out that z equals to 122 plus minus the square root of 7,004 over 4. So here the square root of 7,004 is 83.6899, all divided by 4. So here we have two solutions that are possible for z. The first solution for z is z equals to 122 plus 83.6899 over 4. 122 plus 83.6899 is 205.6899, and if we divide it by 4, we get that z equals to 51.4224. But what is z? Z, according to our definition, is equal to x squared. So if we take the square root of z, we get the value of x, because z equals to x squared. So we took the square root of z, that is 51.4224, and found out that x equals to 7.17 units, but it is impossible that x equals to 7.17 units. Here x is AB, and if you focus on the right triangle, triangle APM, in the right triangle, triangle APM, the hypotenuse AP equals to 5 units, and we know that the hypotenuse is the greatest side in any right triangle. Okay, therefore AP must be greater than the perpendicular AM. So if AP is greater than AM, let alone that AP will be greater than AB, that is part of AM. So you can write here that and AB equals to X. So here, so AP that is equal to 5, that is the quarter of the right triangle APM, must be greater than AM, that is equal to X. So for this equation, 5 equals to AP is greater than AM, that is equal to X, we derive that X is less than 5 units. So X must be less than 5 units, and found out that X equals to 7.17, that is greater than 5 units. So we have a contradiction, therefore due to the contradiction we cancel the solution, and we left only with the second solution, that Z equals to 122 minus 83.6899 over 4. That is to say, Z equals to 122 minus 83.6899 is 38.3101. And if we divide it by 4, we get that Z equals to 9.5775 square units. So the area of triangle of square ABCD equals to X squared. And just like now found out that X squared that is equal to Z, it is equal to 9.5775 square units. So in conclusion, we found out that the area of this square ABCD equals to 9.5775 square units. We finished the first question. Then I presented to you the second question. So in the drawing we have triangle, the right triangle ABC. Inside the right triangle we have a circle, and inside the circle we have triangle DOE, and our mission is to find out the size of this angle theta. So we define DE is 2A, DE equals to 2A according to our definition, and we know that according to what is given us the equation, AD equals to EC equals to DE over 2. AD equals to EC equals to DE over 2 according to what is given us the equation. We substitute DE by 2A. So we have here 2A over 2. We have 2 in the denominator and 2 in the denominator, so 2 will get cancelled, we left only with A. So in conclusion, we found out that AD equals to EC equals to A. So AD equals to A and EC is also equals to A. Then I presented to you rule number 4. According to rule number 4, the perpendicular from the center of a circle to a chord bisect the chord. Here, the perpendicular OM bisects chord CD, that is to say CM equals to MD equals to CD over 2 equals to CD over 2 equals to CM, and CD over 2 equals to MD. We can implement rule number 4 in our drawing, because here, from the center of the circle, we draw perpendicular on chord DE. So according to rule number 4, the perpendicular OT bisects chord DE. That is to say, DT equals to TE, and DT equals to D over 2, and TE is also equals to D over 2. DT equals to TE, TE equals to D over 2, and DT is also equals to D over 2. Because it bisects it into two halves. Each half equals to DE over 2. So here, D equals to 2A, so substitute D by 2A over 2. So we have 2 in the denominator and 2 in the denominator, so 2 will get cancelled, and we left only with A. So I found out that DT equals to A, and TE is also equals to A. Okay, then we define point, we join points O and M together by a straight line. OM is the radius, and the radius is drawn to the point of tendency, therefore this angle equals to 90 degrees and this angle equals to 90 degrees. We join points O and M together by a straight line. ON is the radius of the circle, we have the radius ON that is drawn to the point of tendency, therefore this angle equals to 90 degrees, and this angle also equals to 90 degrees. Inside quadrilateral MOBN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore, quadrilateral MOBN is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, MO equals to BN. But MO equals to R. So for this equation, R equals to MO equals to BN, we derive that BN is also equals to R. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that ON equals to MB. But here ON equals to R, so from this equation R equals to ON equals to BM, we will derive that MB equals to R. So we found out that quadrilateral MOBN is not a rectangle but a square because all of its sides are equal to each other. Okay, there I presented to you rule number 10. According to rule number 10, if we have the external point P, from point P we have tangent PA and a straight line that intersects with the circle point B and point C, then AP square equals to PB times PC. Again, AP square equals to PB times PC. We implemented rule number 10 in our drawing. From the external point C, we have tangent CN and the straight line that intersects with the circles point C and point D. Therefore, CN square will be equal to CE times CD. Again, CN square equals to CE times CD. So CN square equals to CE, that is A, times CD, that is A plus A plus A, that is 3A. So CN square equals to A times 3A. So Cn square equals to A times 3A is 3A square. We took out of this equation and found out that Cn equals to square root of 3 times A. Likewise, we focused on the external point A. From external point A, we have tangent AM and we have the straight line that intersects with the circle at point D and point E. According to rule number 2, to rule number 10, AM square equals to AD times AE. Yeah, AM square equals to AD times AE. So AM square equals to AD, that is A, and AE is 3A. So AM square equals to A times 3A, that is 3A square. So AM square equals to 3A square. We took out of this equation and found out that AM equals to square root of 3 times A. Then I copied triangle ABC. This is the right triangle ABC. Here, BC equals to square root of 3A plus R, and AB is also equals to square root of 3 times A plus R, and we have, so those two sides are equal to each other, and we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if one angle is theta, then the other angle must be also equal to theta. And due to the fact that this angle equals to 90 degrees, the other two angles must be also equal to 90 degrees. That is to say, theta plus theta must be equal to 90 degrees. Theta plus theta is 2 theta. So we found out that 2 theta equals to 90 degrees. We divided this equation by 2 and found out that theta equals to 90 degrees over 2, that is 45 degrees. So each angle is equal here to 45 degrees. Then in this triangle ABC, it is very easy to see that cosine 45 degrees equals to BC over AC. Again, cosine 45 degrees equals to BC over AC. BC equals to square root of 3 times A plus R over AC, that is 4A. Okay, here BC equals to square root of 3 times A plus R over AC, that is 4A. Cosine 45 degrees equals to 1 over square root of 2, so we found out that 1 over square root of 2 equals to square root of 3 times A plus R over 4A. We multiplied this equation by 4A and we found out that 4A over square root of 2 equals to square root of 3 times A plus R. We substituted 4 by 2 times 2, and we substituted 2 by square root of 2 times square root of 2, and found out that 2 times square root of 2 times square root of 2 times A over square root of 2 equals to square root of 3 times A plus R. we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled. And we got that 2 times square root of 2 times a equals to square root of 3 times a plus r. We subtracted square root of 3 times a from this equation and found out that 2 times square root of 2 times a minus square root of 3 times a equals to r. We took a common factor a from this expression and found out that r equals to a times 2 times square root of 2 minus square root of 3. Then I copied the green right triangle DOT in a new page and we analyze triangle DOTO. Point D is the center, point O is the center of the circle, point D is the point of the circle itself, therefore DO is the radius of the circle, that is R. So in the right triangle DOT, cosine theta equals to dt over dO. Cosine theta equals to dt over dO. So cosine theta equals to dt, that is A, so we substitute dt by A, over dO. dO equals to R, so we substitute dO by R, and found out that, so cosine theta equals to A over R, and we have already found out that R equals to A times 2 times square root of 2 minus square root of 3, so we substitute R by A times 2 times square root of 2 minus square root of 3. We have A in the numerator and A in the denominator, so A will get cancelled. In conclusion, we found out that cosine theta equals to 1 over 2 times square root of 2 minus square root of 3. In order to find out the value of theta itself, we operated the opposite function of cosine, that is cosine minus 1, on the result, and in this way we got the value of theta itself. So if we operate the opposite function of cosine, that is cosine minus 1, on the result, that is 1 over 2 times square root of 2 minus square root of 3, we will get that it is equal to 24.203 degrees. So we found out that the size of this angle theta, is equal to 24.203 degrees. Okay, repeat again, the size of this angle theta, it is equal to 24.203 degrees. Okay, thank you very much.